Hi everyone, in this video we are going to discuss about how to factor quadratic trinomials which are not perfect square. And I have two flavors of that on the screen right here. We have first flavor is where the coefficient of x squared is 1, and in the second flavor the coefficient of x squared is something other than 1, right? Now, how do we form a quadratic expression? And if we factor a quadratic expression, how are the factors going to look like? Now, there is one thing that we must understand, that the factors of a quadratic expression will be all linear factors. When I say linear means the highest degree of x would be 1. Now, let's take two linear factors like this and see if we multiply them, how the quadratic expression going to look like. So suppose we have two factors like this, x plus p and x plus q. Let's suppose those are the two factors of a quadratic trinomial, and if we multiply them, that should give us the trinomial. So from here, let's try to multiply it and see what happens. So if we remove the parenthesis, it will look like x squared plus qx plus px plus pq. And if we simplify this a little more, we are going to see x squared plus, we can combine the two middle terms there because they both have x as the common factor. So I'm going to write it as p plus q times x and then plus pq, which is the constant term here. The third term is the constant term there, right? And now if you carefully look at it, you will notice that we have product of two numbers which are p and q, and then we have their algebraic sum as the coefficient of x, which is right here. You see this p plus q is actually nothing but the algebraic sum of the two factors of this constant term. So now what are the different factors that we can get for this constant term? Well, let's try that and see how that looks. So for pq, we can have two factors as p and q, positive p and positive q, because if you multiply them, that will give you positive pq. And similarly, we can have 1 and pq, that could be another combination. Also, we can have negative p and negative q. Would there be any other combination? Well, yes, we could have negative 1 and negative pq. Are there any other factors possible for pq? If you assume that pq is nothing but a number, what are the different ways that we can create factors for that number, right? And because it is an algebraic number here, we are going with pq, right? But if it was an arithmetic number, then you should be able to do the prime factorization or even non-prime factorization to come up with a pair of factors. All we have to do is we have to try and find out what are the possible pairs of factors. I'm talking about pair, right? Meaning two of them. So here, I think these are all the possible pairs of factors of pq. Now, let's try to pick one such combination whose algebraic sum would be positive p plus q. Now, which combination do you think would give us positive p plus q if you take the algebraic sum? I think this is that combination which is positive p and positive q. This combination will give us the algebraic sum as positive p plus q. So as you can see, the coefficient of x in the middle term there, it is nothing but the algebraic sum of the pair of factors of p times q, which is actually the constant term, right? So the pair of factors of the constant term, its algebraic sum is actually sitting in the middle term there. And if we assume that this particular expression, which is x squared plus p plus q times x plus pq, is factorable, then we can assume that yes, the coefficient of x is nothing but the algebraic sum of the pair of factors of pq. It could be any of these combinations, but we have to pick the most suitable one where the algebraic sum of the pair would be the coefficient of x in the middle term. Now let's take an example. Say suppose we have an example x squared plus 5x plus 6. So I'm going to go with that example. Now here the constant term is 6, which is actually equivalent to that pq term. So now what are the different factors we can get for 6? Well, for 6 we can get all these combinations, right? We could have positive 1 and positive 6. We could also get a negative 1 and negative 6. We could also get a positive 2 and positive 3. We could also get a negative 2 and negative 3. Are there any other possible combinations? I guess that should be it, right? For 6. Now from here, we have to pick a suitable combination which will give us 5 when we take their algebraic sum, meaning whose algebraic sum would be positive 5. Now, as you can see, the only combination that I can see here is this combination, the third one right here. This combination will give us 5 if we do the algebraic sum of the factors, right? So then can we write it like this? So I'm going to write this thing as x squared plus, in place of 5 I'm going to write as 2 plus 3 times x plus 6 right here. Now from here, can we write it like this? So now let's remove the parenthesis. So this is going to become x squared plus 2x plus 3x, 3 times x plus 6. And then from here, now if you look at the first two terms right here, and then also we'll be looking at the next two terms separately. But let's first look at the first two terms here. What is the common factor? Well, it looks like x is a common factor between the first two terms. So if we take that out, then we are going to get x plus 2. And then from the next two terms, again you see we have a common factor which is 3. So if we write 3 like this, then we are going to get x plus 2 again. And now you see that x plus 2 is a common factor now between the two big terms here, right? Now we have two terms and there is a common factor which is x plus 2. So let me write x plus 2 outside, x plus 2, and then we are going to be left with this x right here and the positive 3 right there. So now we are going to say, okay, this must be then x plus 3, and that is the factor form. So our original expression, which is x squared plus 5x plus 6, can be written as x plus 2 times x plus 3, and this is the factored form of our original expression. I hope you are able to follow the steps. Now let's take another example. So suppose we had another example up there, which is x squared minus 7x plus 10. Now what is the constant term here? Well, the constant term is 10. So we want to find out what are the different factor pairs we can get for 10. Well, one pair could be positive 1 and positive 10. So I'm writing it like this. Another pair could be negative 1 and negative 10. Another pair could be positive 2 and positive 5. And another pair could be negative 2 and negative 5. Are there any other combination possible? We have to factor 10 into two suitable factors, right? So I think those are the possible combinations that we can get for positive 10, right? Now from here, we have to pick such a combination that will give us negative 7 as their algebraic sum. So for example, right here you see the negative 7 that we have as the coefficient of the middle term, coefficient of x. We have to pick one such factor combination from this list of 4 pairs whose algebraic sum will give us negative 7, and you can clearly see that that combination would be this one right here, right? So now let's go with that combination and see what happens. So from here I'm going to write it like this. So we can say, okay, x squared plus negative 2 and negative 5, that is our negative 7 times x plus 10. And then from there, can we remove the parenthesis and see what happens? So this will be x squared, then minus 2 times x and minus 5 times x plus 10. And then from there, can we write it like this? Now, if you look at the first two terms here, we have a common factor. And then if you look at the second two terms also, there is a common factor. So let's handle the first two terms first and then see what happens. So from the first two terms, if I take x as a common factor out, then within parenthesis we are going to be left with x for the first term and then a negative 2 for the second term. And now if you look at the third and the fourth terms there is also a common factor. Do you see that? Well, negative 5 is a common factor. So if we take negative 5 as a common factor, so I'm going to take negative 5 as a common factor, then we're going to be left with a positive x for the third term and a negative 2 for the fourth term. And now you see that x minus 2 is a common factor between the two big terms that we have now, right? So now we are actually dealing with two large terms, and from there again x minus 2 appears to be a common factor. So from here I am going to take x minus 2 out, and then from the first term what we are going to be left with? We are going to be left with the positive x. So let me write it here, positive x, and then from the second big term we are going to be left with a negative 5. So this will be x minus 5. And this is the factored form of our original expression, which is x squared minus 7x plus 10. I hope it made sense so far. Now let's talk about the second flavor of this quadratic trinomial, where the coefficient of x squared is not 1. It is something other than 1, right? So let's take a situation like that. Let's try two generic linear factors like this. So suppose we have ax plus b times cx plus d, right? Suppose we are multiplying these two linear factors and we'll see how the quadratic trinomial turns out to be. So now if we multiply them, what we are going to get? Well, from here we are going to get something like this. We'll get a times c times x squared, and then we are going to get a times d times x. Next we are going to get b times c times x, so that would be b c x, and then finally we are going to get b times d. That's our constant term. And then if we reorganize a little bit, so first one would be a times c times x squared plus, now within parenthesis I can write a times d plus b times c multiplied by x, because x is a common factor between the two middle terms there, and then finally the constant term which is b times d, right? Now if you carefully look at it, you will notice that this a times d plus b times c, this looks like an algebraic sum of two factors of the constant term and the coefficient of x squared multiplied together. Suppose if we multiply a times c, which is the coefficient of x squared, with the constant term which is b times d, then what we get? Well, we get a times b times c times d, right? And now let's try to come up with a pair of factors of this product, which is a times b times c times d, the abcd, that particular number. Let's try to come up with a pair of factor for that number, and let's see what are the different pairs we get, right? Okay, one pair could be positive a and then b times c times d, that would be another factor. Also you could have a negative a and then a negative b times c times d. And then similarly we could have a factor like, for example, a positive a times b and then positive c times d, or even we could have a negative a times b and negative c times d. These are all possible. Similarly we could also have a positive a times c and positive b times d, and also you could have a negative a times c and negative b times d. Similarly we could also have, say suppose example, positive b and then positive a times c times d. We could also have a negative b and negative a times c times d, and similarly you can create many more combinations like this, right? Also you could have another pair like, for example, let's say a times d positive ad and then positive bc, that could be one combination. And also you could have a negative ad and then negative bc. There are many more combinations possible, right? Say suppose you could even say, hey, what about c and then abd? Yes, that is also another combination. You could say, okay, how about ABC and D? Yes, that would be also another pair of factors of this large number right here, right? So we are talking about this number, the A times B times C times D. We are trying to come up with a pair of factor of that number. Now from these pairs, can you find out one such pair whose algebraic sum would give us AD plus BC? Well, I can already see that, and this is that combination that I have carefully chosen right here. This is that combination whose algebraic sum would give us AD plus BC. So we have to go with that combination to factor this expression. Now I'm going to take an example. We had a couple of examples up above, and I'm going to take one of those examples. Let's first try the 2x squared plus 5x plus 2, right? So now what I need to do, the first thing would be we have to come up with the product of the coefficient of x squared and the constant term. So that product would be 2 times 2, which is 4, right? And then we have to now create pair of factors for 4. So what are the different pairs we can create? Well, for 4 we can say, okay, positive 1 and 4, that is a combination. About negative 1 and a negative 4, that is also a possible combination, because if you multiply them it will still give you positive 4. Then how about positive 2 and a positive 2? Yes, that is also possible. How about a negative 2 and a negative 2? Yes, that is also possible. Now are there any more pairs possible? I think we are done. I think that's it, right? Now from these combinations we have to pick such a pair of factors whose algebraic sum would be equal to positive 5. And I think you can already see that this should be the pair that we want to go with, that will give us a positive 5 when we add the factors there. And what are those factors? Well, those are actually the factors of 4, positive 4. And what is positive 4? Well, it is the product of the coefficient of leading term and the constant term. So in this case it is 2, which is the coefficient of x squared, and the constant term is also 2. We multiply them, then we come up with 4, and then from 4 we try to find out a suitable pair of factors of 4 whose algebraic sum would be positive 5, which is the coefficient of the middle term. So now we are going to go with this pair, which is positive 1 and positive 4. So what I'm going to do, I'm going to now write our expression like this. We can say, okay, so 2 times x squared, that's the first term, I'm going to keep it as is, and then for the positive 5 I'm going to write it like this. Let's say 1 plus 4 times x and then plus 2. So that is our expression. And then now let's remove the parenthesis. So we are going to get 2x squared plus 1 times x, which is x, plus 4 times x, which is 4x, and then plus 2. And from here, now if you look at the first two terms, we have a common factor. What is that common factor? Which is x. So now we are going to get 2 times x plus 1. And then from the last two terms here, there also we have a common factor. Do you see that? We have a common factor which is 2. So from there we can say, okay, there should be 2 times 2x plus 1. And now from these two large terms, you can see that we have a common factor which is 2x plus 1, 2 times x plus 1. That is a common factor, right? So then let's take the common factor out. And if we take the common factor out, it is going to look like 2 times x plus 1 like this, and then we are going to be left with a positive x here and a positive 2 right there. So our remaining items would be like this. We will have x plus 2, and this is the factor form of our original expression. I hope you are able to follow the steps. Now let's also take the second example that we had up there, and that example was actually 2x squared plus 5x minus 3. So let's try that. Now here, what is the first thing we need to do? Well, we need to first multiply the coefficient of the leading term with the constant term. So that would be 2 times negative 3, and that gives us negative 6. And then we want to factor negative 6 into all possible combinations. So suppose one combination could be a negative 1 and positive 6, or positive 1 and negative 6. We could also have a negative 2 and positive 3, or maybe positive 2 and negative 3. Now any other combinations possible? I think that should be it. I am not seeing any other possibility. So now from these four possible pairs of factors of negative 6, we need to pick one such pair whose algebraic sum would be equal to positive 5. And what would be that pair then? I think this pair would give us positive 5 if we take the algebraic sum of each of those factors there from that pair, right? So let's proceed with that. So now then we can say, okay, then our original expression can be written as 2x squared. That's the first term. We're going to keep it as is. And then for the second term, I'm going to write it like this. I'm going to say, okay, you must be a negative 1 plus 6. That is our positive 5 times x and then minus 3. So the positive 5 now has been written as the algebraic sum of the two factors of negative 6. And what is negative 6? That is the product of the leading coefficient and the constant term. So from here, what do we get? Well, now let's remove the parenthesis. So we are going to get 2x squared minus x, 1 times x means x, and then plus 6 times x, that would be positive 6x, and then minus 3. And now we are going to look at the first two terms together, and then we will look at the next two terms together. From the first two terms, do we have a common factor? Yes, we do. That common factor is actually x. So then we are going to be left with 2x minus 1. And then from the next two terms, do we have a common factor? Yes, of course we do. That's the positive 3. So if we take a positive 3 outside of the parenthesis, then we are going to be left with 2 times x minus 1. And now you can see that we have a very nice situation here. So here again we have 2 times x minus 1 as a common factor between the two large terms that we have now. So from here we can say, okay, then this must be 2 times x minus 1. So I am taking the common factor out, and then we are going to be left with the positive x there and the positive 3 there. So that would be positive x plus 3. And this is the factor form of our original expression. I hope everything made sense. Thank you for watching. See you in the next video.